And so it basically, the water splits up this hydrogen and this chlorine, and what you get are two ions now all of a sudden. The chlorine gets the extra electron from hydrogen, and the hydrogen's left with nothing. And that makes the hydrogen super, super, super reactive. It has to go somewhere because that lack of an electron makes it very unstable. And so what it almost always does is it latches right onto this water molecule, and it forms a curious little creature called the hydronium ion, where now you have a positively charged extra hydrogen attached to the water. Just a reminder, or kind of a point of emphasis, the halogens, the group 17s, so iodine, fluorine, chlorine, bromine, these guys are the halogens, and they are super strongly attracted to hydrogen-based compounds because they need one more electron, and lo and behold, hydrogen has its one electron. And so they always form a polar molecule in that type of a relationship. They also, because that hydrogen's one electron is pretty easy to pull away from it, it causes them to be very strong electrolytes. They can pretty easily dissociate into two ions, into the hydrogen and the bromide, or any of the other ones. There are some other polar compounds that will form ions, but not very high concentrations of ions, and so we call them weak electrolytes. They do have some charged particles, but not a lot for the amount of total solute that's present. And then we have, you've seen this one before with sugar. Sugar, no matter what you do to it, the bonds between the sugar molecules are far more attractive and far stronger than any kind of bond that sugar might have with water. And so there's no dissociation at all. There's no ionization happening there. Okay, so that's it for today. Let's have you bring in some clarification questions and write your summary, and we will do a bunch of dissociation and ionic equation writing in class. I'll see you soon.